So staying within prescription through the entire burn, not just when you start, but through the whole time that you're burning is a critical thing. And so how we do this, I'm going to take you to a website so that you can and work you through this a little bit. But it's a really critical thing. So what it means is that that prescription that I just gave to you, it means that you shouldn't be dropping below 20% relative humidity. You shouldn't be able to measure that at the beginning of the burn, but you should be confident that relative humidity is going to stay above 20% all the way through to when you end that fire as well. So that you've got a period from when you start to when you end, and you need to be within prescription during that entire period, not just to get started with that. So since you know that there's a pattern in relative humidity, that relative humidity tends to drop during the day, one of the things it means for a prescribed fire is you don't tend to light fire at 10 o'clock in the morning if you don't think you're going to finish until 6 o'clock in the afternoon, because that means that you're going to have relative humidity that is starting at a very high level and is going to decline throughout the day, and you're not sure if that forecast will be correct. So you would be more worried that you might have your relative humidity drop too low to be within prescription. A way to avoid that would be to start that same fire, say at 3 or 4 o'clock in the afternoon, where you're starting the fire at the minimum relative humidity that you're expecting to get during the day, and then you know that relative humidity is going to go up as the nighttime advances and temperatures drop, and so relative humidity increases. So from the point of view of a prescription, you want to be making sure that that period of time is going to be appropriate for the prescription that you're using, and oftentimes that means starting it later in the day rather than earlier in the morning. Now, lots of people do burn in the morning and they can burn successfully, but generally they're doing relatively short burns, say from 11 to noon, and so your relative humidity isn't going to have the ability to change very much within a 1 hour time period, and so that can fit very well. But there's other things that follow that daily rhythm of weather, which are winds tend to take a while in the morning to become constant and to blow at their true strength. And so you want to be well past that period so that when you're measuring wind speed or wind direction, that it's standard. And so there's a lot of things that you want to keep in mind to stay within prescription through your entire burn, basically. So the tools that we use for this is a really slick tool, and it's easily available. So it's at NOAA.gov, and so this is the general NOAA website for weather. And so I'm going to pull out of this and go into my email, and I'll show you how to get to that. So you can see what a boring life that I deal with. All I have to do is type in N, and I've got NOAA.gov coming up. And so I hit that. And so now this is the landing page for the NOAA website. And you can see I've already got a location that's preloads on my computer because this Arena, Wisconsin is near me. And so typically I want to see what's going on near me for burns that I'm doing in the area. But let's change this. So all you have to do is hit that. And to see, you can see this square, and it says to see the full forecast. I can type my location in here by hitting that and typing the location. So let's go to Spring Green, Wisconsin. And so here it's popping up with Spring Green, so you can click on it and say go. And so now I have Spring Green, Wisconsin. This information is meant to allow you to tell what's happening during the day at a glance, but I don't find it very useful for prescribed fire forecast, but I will show you a very useful forecast. But one of the first things, so this green dot is where Spring Green, Wisconsin is. This is the Wisconsin River right here. But one of the cool things about this is you can actually get a forecast for any spot that you want to look at for a prescription. So this spot, if you go up, this spot is located at this coordinate. And where is my, somewhere here it will tell me where I am, but it's not, I can't see that for right now. Normally it, well, let's do this. So let's say that we want to go in a different spot and we're going to burn at the Sauk Prairie Recreation Area. And I don't know, whoops, sorry about that. And I know for sure in the Sauk Prairie Recreation Area that I'm going to be burning right here, which is the terminal moraine. This is the terminal moraine right here. And I'm going to be burning right on top of the terminal moraine right in that location. So I tap that. And you can see now that this green dot is there. And so this is an extended forecast for a point that's 5 miles north of Prairie du Sac, Wisconsin. So here's Prairie du Sac, here's 5 miles north. So it's giving me the forecast for precisely that area. So now I have my location determined, and then you can click on this graph for hourly forecast of the weather, and you can see this information come out. So what you have here is this is saying for Thursday, April 4th, this is the temperature. It's going to be low as we typically expect. In the evening, it's going to rise to 42 degrees Fahrenheit, and then it's going to drop down on Friday afternoon. Wind speeds are going to be coming from the north. That's what this flag means. They're going to be blowing 13 to 15 miles an hour during the afternoon. They're going to be gusty in the morning, but those gusts should disappear by noon. So if we were going to do a prescribed burn, we would have an appropriate temperature. We would have a high wind speed, but it's an appropriate wind speed in the afternoon, in particular later in the afternoon. The direction isn't changing. It's pretty much north the entire time. But at 7 p.m., it's 9 miles an hour, and at 1 p.m., 15 miles an hour, and it should be steady but dropping during that period. If you look down here, it's saying there's a high chance of precipitation, and that precipitation is supposed to be snow, mostly at 7 a.m., and that precipitation should drop off to a fairly low chance of precipitation during the afternoon. But the minimum relative humidity, the relative humidity here is going to stay very, very high. So it's going to be up 76%, and it's going to be mostly cloudy during that period of time. And there is some chance of rain during this period too, a small chance, 13%, but that's what these bars are indicating. And so what we're saying, if we're interested in doing a prescribed burn, we check on the wind, at least in the latter part of the afternoon, check on the temperature. The rain frequency isn't too bad, but we've got an accumulation of snow that's supposed to occur so that snow might be lingering. So in terms of moisture from precipitation or days since the last rain, and in terms of minimum relative humidity, we would have a difficult time being within prescription because it would be too wet for that time. But if we looked at Friday in this particular area, we have 44 degrees Fahrenheit. We have a northeast wind at 9 miles an hour, minimum relative humidity of 60%, a chance of rain at 10%. And so for Friday, we have much better conditions that we might have to do that prescribed burn, at least from what you can see up here. And so now, unfortunately, we've had on Wednesday today, we've had about 5 inches of snow, and in addition, getting another inch of snow. So this snow isn't going to be melted by this time. So the snow kind of complicates that. But if you weren't paying attention to the amount of snow already on the ground, you would be barely in prescription for relative humidity, pretty good for precipitation, wind speed, and presuming there's no restriction on wind direction and temperature, you're pretty good to go as far as those characteristics are concerned. If you want to see some of the fire weather, you can turn these on and hit submit. It'll take a little bit to think about that. And here we've got a new thing. So we see our old forecast that we saw here, but basically we've appended the fire weather kinds of metrics here. So here we have mixing height of, it's going to max out at roughly 27,000 or 2,700 feet. So we have appropriate mixing heights here, but basically after about 5 o'clock, it's crapping out. And so it's not high enough of a mixing height after 5 o'clock p.m. The Haynes index is a measure of smoke dispersion, so it's okay, but it's quite low, and you don't need to cover that for right now. And the transport winds are quite strong, and they're coming north-northeast, 17 to 28 miles an hour at the mixing height. And then finally, a ventilation rate is at about 58,000, maxing out 58,000 mile per hour feet. It's an odd metric, I understand, but that's how it's measured. And this is basically saying how much is the smoke dispersing out into the air in general, which is a very good way of thinking about, is the smoke going away or is it staying concentrated? And generally you want this to be above 32,000. And so we have that from 1 p.m. to after 4 p.m. it's getting below 32,000. This is a logarithmic scale, so it's a bit of a bugger to read. And I don't know why they have it scaled quite so low, because it's almost always within this. And so these fairly big changes, it's hard to see. So, but basically this means that we're good until about 5 p.m. After that, it's maybe getting a little bit too low, but it's a bit hard to read this. So the difference between 32 and 26,000, it's hard to read. And this is sort of good ventilation rate, just barely, and not good ventilation rates here. So this is the kind of forecast that you can get, and this is where you would go to look to see if you're staying within forecast. And so all you have to do is say, if it's gonna take me 3 hours to do this prescribed burn, then if I start at 1 p.m. and I go until 4 p.m., that's 3 hours, I should stay at 9 miles an hour. My wind direction should stay steady northeast. My temperature is not going to change appreciably between 1 and 4 p.m. It's going to go up 3 degrees and stay at that. My relative humidity is not changing appreciably during that time. So I'm good for that period of time. And what I physically do is I actually will go, when I print these out for a prescribed burn, I'm going to do is I'll draw a bar here and draw a bar here at 4 p.m. and a line between them. So I'm telling myself that I'm looking at exactly this time and I'm saying, am I going to be within prescription during that time? Because it's real easy to look at all these numbers and say, yeah, that looks good, without really thinking about it. And so I physically draw in the boundaries of when I'm planning to do the burn to see if I'm staying within prescription during that whole time. All right. So if I go back to the presentation, that's NOAA.gov. Now, one of the things, if you take a very close look at this picture, this is a prescribed burn that I did actually at the Sauk Prairie Recreation Area before it was a Sauk Prairie Recreation Area. And you can see a problem that I've ran into in this burn while I was doing it. Think about what that problem would be as you're looking at that picture. And then when we meet when we meet in person, we can talk a little bit more about this picture. But there is a problem that I did not take into account my prescription well enough, and I had a problem doing this burn. Now, let's talk about things other than weather in affecting prescribed fire or fire behavior. So in general, slope, fire travels uphill faster than it travels downhill. And so fire traveling up a hill is like fire going with the wind. It will go as quickly as possible. And fire going down the hill will be like fire backing against the wind, so it will go quite slowly. The reason why fire travels up a hill fast is it preheats the vegetation, which is above it. And you can see in this picture that fire is going up this hill very, very rapidly. And the fire pushed by the same wind down here is not going very fast at all. You can see flame lengths that are variable, but still quite low. This is a 1/2 foot flame length. This is maybe 3 foot flame lengths, but these flame lengths are probably 30 feet. And so on this steeper slope, the fire is going much more rapidly up that slope. And on the flat ground, the fire is not going so rapidly because it doesn't have that slope driving it. Even though the wind is pushing in both these characteristics, you can see that this is when it's slope and wind, it's a much different kind of fire than here, where you've got slope and wind here. And this is a picture that I've found very interesting. This is a picture that was drawn in the 1800s about fires lit by Native Americans and seeing how they would burn. And you can see the same sort of behavior that they noticed. So this is a person who's depicting very real things, I think, because they're showing the fire behavior going up a hill faster than it goes on flat areas, which is exactly what we see here. Um, Shape of the topography can alter wind direction, but it also can influence wind speed. So if you think about a rapids, when water is coming down a river and all of a sudden it meets a narrowing of that river channel, the same amount of water has to flow through a narrower volume. And so for that to happen, it has to go faster through that channel. Wind will do the same thing. So when wind is blowing across an open landscape and it encounters a narrow constriction, it's going to act just like that water in a rapids and have to go faster to move the same volume of water through a narrow volume of a channel. And so it will go much more rapid through that. And I'll give you an example of that. And aspect, the slope's exposure to the sun generally tries to, or generally dries out areas. They're warmer, they're drier. So south and southwest slopes generally are warmer and drier than our east slopes and north slopes. Barriers such as streams and roads and rock outcrops can also influence fire behavior. So let me give you a couple examples of that. So these are real burn units that are in Sauk County. This is a burn that originally we came around, we are burning this whole bluff here, and this red line is where we used to put the fire break. And the first time that I did this unit as a whole, um, the crew, basically this whole slope here, which is a north aspect, it's facing this way, the crew barely got anything to burn throughout this whole area. And the crew coming around this area was having a great burn in this. And so they had come along this line and they had this all burned out and everything was going great. This crew couldn't get anything to light. And so they came up to the top of this slope. Things still weren't lighting very well. And so they thought, we don't have to be very careful with fire. And so they lit a fire from the top of the saddle all the way out here. And they only had 4 people on their crew. And so this is basically almost a quarter of a mile that they spread their crew out. The problem is that we had out here, we had 10 miles an hour winds. But with this bluff here and this bluff here, the wind going through this channel was blowing much more rapidly. So a 10-mile-an-hour wind out here was a 25-mile-an-hour wind here. And when I came along and I came around this bend and saw that they had this whole line lit, I walked out to the area that I thought that we would have a spot fire. And sure enough, it happened right at my feet, but the wind was blowing so strong, I couldn't put it out. And so that fire went up the bluff here, and this was the only fire that I've ever had that escaped. Now, so the couple lessons here is slope or aspect had a big bearing so that things would not, we are out of prescription and not productive burning this north aspect, and we are in prescription and able to burn very well on this aspect. But these bluffs channel wind through this smaller volume corridor through here. And one of the things that we've done in subsequent years, so as to not repeat that mistake that I made, is we no longer run our brake through here, but we run our brake over here, come up to the top of the bluff here, and then come out here. So basically the wind never is pushing directly against our fire brake. It's always kind of slanting or bouncing off of it. And I'll give you more precise terms in the following lecture. But basically, we changed the configuration of this unit so as to not have the problem with this really strong wind hitting our back line squarely in this circumstance, and we've never had a problem burning since then. So the two lessons are aspect matters in terms of whether you're in prescription or not, and wind speeds can be influenced by the shapes of the hills around it. But another example is this in the same area, but a different burn unit that's here. And we had a southwest wind. So north is the top of the page. And we had a southwest wind. And we started our fire up here. And one crew went here, down around here, and up this way. And another crew went this way. And what was really cool with a southwest wind is when this crew was lighting, they were lighting fire that was wanting to go up the hill. And when they turned this way, the fire was going with the wind in this direction. But on this side, as the wind came over the top of this hill, rather than it above the bluffs, it continued as a southwest wind. But when it was down in this valley, it actually came down in the valley and came back up the hill. So it basically created a vertical eddy. So it came down around and then back up. So this is exactly like what you would see in a river, except in a river, it's on a horizontal basis. So if water's coming up to a rock, it comes around the rock, going downhill, but then it comes back upstream behind the rock. And that's what an eddy is. So and then it will circle around. And this is an eddy, but instead of on a horizontal basis going like this, it's a vertical basis going like this. So the air is tumbling around like that. So basically, with a southwest wind on this unit, the fire was going up the slope, up the slope, up the slope, up the slope, up the slope. And then finally, when you got out here on the flat ground, it was a southwest wind. So this whole hillside had fire going up the slope in all directions with a southwest wind. So that the slopes were determining what the wind direction was doing on these slopes. And that's what I mean when I say that on these slopes, wind direction takes on a lower significance because the slopes are determining what that wind and therefore what that fire is going to do in almost all cases. Now, on flat ground, you don't need bluffs in order to have local effects of the wind. In this case, if we have the prevailing wind direction going like this, let's call this a west wind. So it's coming out of the west and it's blowing in this direction, especially if it's light. When you've got a forested situation, so you've got a bunch of trees that are here and an open area here, if the wind's blowing in that direction, out a distance from those trees, the wind's going in this direction. So the fire moves in this direction. But when the wind, especially a lighter wind, say a 3 mile an hour or 5 mile an hour wind, comes and hits these trees, it will bounce off those trees and it'll go back. So this is like that vertical eddy, like what we talked about in the bluffs, and it will go back. And so when you're close to the trees, you'll see the fire go in the opposite direction. Now, if you're on flat ground and you can see the wind's supposed to be going in this direction, but you see the fire going in the opposite direction, this would be a bit disconcerting because you're thinking, oh, has the wind changed directions and do I have a problem here because I've got a change in wind direction? All you need to do is look up so that even though the fire and the smoke will go in this direction, when the fire gets up above the trees, it's going to go with the prevailing wind. So if you look at the fire going in this direction and you look at the smoke when it gets up above the trees and it's going in the same direction it should be with the prevailing wind, you say, oh, this is a local effect. It's just bouncing off the trees. And so the fire generally, will start to go in the opposite direction once it gets far enough from those trees, which is generally about 10 to 20 meters. So trees or tree lines can affect wind direction on a local basis, and you can tell the difference between a local effect versus the prevailing wind or the change in the prevailing wind by simply looking up above the elevation of that obstruction and seeing if the prevailing wind is taking the smoke in the direction you would expect, or if indeed you really had a wind shift and the smoke is going in the a direction that's inappropriate. Look up. This is an example of a vertical eddy, but it's in a different direction. So here the wind is coming up against this building, and then it gets above the building and going with the prevailing wind. So the prevailing wind is coming from the left, going right, and this smoke is catching it. But down here, it's eddying around and coming back towards the building and coming up around. So we use this to our advantage in that we keep the smoke away from the crew, and we keep the building from being affected by putting water on it. But you can see what a wonderful job this is keeping people out of the smoke. And this is essentially the exact same thing that's happening on the bluffs that I just showed you. But here you can actually see the smoke doing it on a smaller scale. So that's the effect that topography has on fire behavior. And so I just want to talk briefly about fuels. So fuels can determine fire behavior by their load, which is the amount of biomass that's there, the size of the fuel, so that how intensely they're going to burn, and that can range from dust particles to logs, how they're arranged, are they loose or tightly fitted, and then how much moisture is in them. So those are the four kind of parameters that are relevant for fuels. There's probably a fifth one, which is what the fuel is made of. So grass is can burn more easily than say dense wood versus light wood. So that we have things like if you burn with wood, BTU contents of oak is much greater than it is say of popple. So that would be another component, but it's of less significance when you're talking about prescribed burning. So primarily you're looking at how much biomass is there, how big is the actual fuel, because that determines how quickly it's going to dry, how it's arranged, is it loosely fitted or tightly fitted? So is there a lot of oxygen in it or not? So that would be the difference between coal and grass that's intermixed, and then how much moisture is in it. So all those things influence how hot or what the fire behavior will be like. So you can see examples of size, of load, or intermixing, and say here in sands, we used this example earlier for this. Now, how this interacts with, say, weather parameters is if you have fire is a very intimate sort of mechanism because it has to touch things in order to be able to move. Fire itself doesn't really move. It burns up the fuel that's there, and if there's no other fuel that is touching, it goes out because remember the fire triangle, fuel is one of the legs of that fire triangle. If you remove the fuel, there's no fire. And so in the case if fire can't touch anything new, it's going to go out because it's removed the fuel and therefore it will go out. In a sparse arrangement here, fire can't touch something unless wind is occurring at a high enough velocity that either flame length or embers or preheating can occur so that fire is touching the next piece of fuel that's going to burn. And so fuel arrangement, that's how that essentially works. So here it's fuel, here it's mixture of oxygen with easy to burn vegetation, which influences fire behavior. And here it's the intensity of the heat coming off of this bigger fuel when it starts to burn. If it has low moisture content, creates a great deal of intensity. So that's what I wanted to talk about with fire behavior. And what we will talk about next is how to take that fire behavior and then begin implementing it in terms of using that fire to implement a prescribed burn. And I look forward to talking with you. Thank you for your time. And I look forward to talking with you on the next lecture. Good night.